All right, so we are working on our pre-cal exam 3 review, and we're going to do some of the problems that are associated. So the first one we're looking at is sine theta, secant theta. And we are trying to simplify trigonometric expressions. So all we're doing is we're going to simplify. We don't know what it's equaling. We're trying to figure that out. So first thing you want to do is change these to sine and cosine. So sine theta secant theta will equal sine theta, because that's already in that form. And secant theta, we know, is the same thing as 1 over cosine theta. Well, these are being multiplied here. So sine theta times 1 will get us sine theta on the top, and that gets us cosine theta on the bottom. And sine over cosine is the same thing as tangent theta. The second one we're going to look at will be tangent squared x minus secant squared x. So again, the first thing I want to do is write things in terms of sine and cosine. So tangent is the same as sine over cosine, like we just discussed. So that gets me sine squared theta over cosine squared theta minus secant, again, is 1 over cosine. So this will be minus 1 over cosine squared x. Oops, I'm sorry, these should be x's, not thetas, because we have x's in this problem. They're about the same thing. It's just determining the terminology you want to use. All right, I notice that these have the same common denominator. So I'm going to combine the top, so sine squared x minus 1 over cosine squared x. Well, I know that from the Pythagorean identities that this should get me cosine squared x. But normally, with my Pythagorean identity, I have sine squared x plus cosine squared x is equal to 1. And if I want to solve for where I'm solving with sine squared and 1, I would normally subtract my sine squared x over, and that would leave me with cosine squared x is equal to 1 minus sine squared x. But I notice that my signs are different on this over here. I've got sine squared x minus 1 instead of 1 minus sine squared x. So I'm going to multiply both sides by negative 1. So that gets me negative cosine squared x is equal to negative 1 plus sine squared x. Well, negative 1 plus sine squared x is the same thing as sine squared x plus, sine squared x minus 1. So that tells me that my sine squared x minus 1 is equal to negative cosine squared x. So now I can say that this equals negative cosine squared x over cosine squared x. Well, negative cosine squared x over cosine squared x is the same thing as negative 1. All right, the next one we want to look at is secant theta minus cosine theta all over sine theta. So secant theta is again 1 over cosine theta minus cosine theta all over sine theta. So everything is in terms of sine and cosine. So what do I want to do with this? Well, I want to figure out how to simplify this down. A lot of times we try and take this and get common denominators, but if I just multiply this by cosine, I can get rid of my denominator and get a 1, and then multiply this one by cosine, I would get cosine squared. Well, 1 minus cosine squared would simplify down using my Pythagorean identity to sine squared. So that's what I'm going to do. I want to multiply the top by cosine theta, and whatever I do to the top, I have to do to the bottom, so I multiply the bottom by cosine theta. So that's basically multiplying by 1. So this now becomes cosine times 1 over cosine will get me cosine theta over cosine theta minus cosine times cosine gets me cosine squared theta. All over sine theta times cosine theta. Well, I know that cosine over cosine is equal to 1. So now I've got 1 minus cosine squared theta all over sine theta times cosine theta. So now I'm looking at what can I do with this? Well, 1 minus cosine squared theta is equal to sine squared theta through the Pythagorean identities, all over sine theta times cosine theta. Well, now I can take my exponents, because this is to the 1, so sine squared over sine to the first, I can cancel that out. 2 times 1, or 2 minus 1 is 1. So now I have this equal to sine theta over cosine theta, which will equal tangent theta. So, and the reason we can cancel this way is because we have multiplication happening. All right, so the next problem we are looking at is number 4. And number 4 has a fraction in it. So we have 1 over 1 minus sine theta plus 1 over 1 plus sine theta. So with this fraction, we still are looking to simplify. So first thing we got to do is get a common denominator. So this will be 1 minus sine theta times 1 plus sine theta for our denominator. Minus sine theta times 1 plus sine theta. So what did I multiply this denominator by over here to get here? I multiplied by the 1 plus sine theta. I had a 1 up there, so just in case it's something else, we want to get in the habit of writing everything. So 1 plus sine theta. This will be 1 times this denominator got multiplied by this, so it's 1 minus sine theta. So this gets me 1 plus sine theta plus 1 minus sine theta, and these are over the same denominator, so I'm going to go ahead and combine them to be 1 minus sine theta times 1 plus sine theta. So now I can combine like terms on the top. I have 1 plus 1 will get me 2, and sine theta minus sine theta cancels out. Well, I want to simplify down, so I'm looking at my denominator and I see that these are really the difference of squares. I have the exact same thing in both parentheses, except one has a minus, one has a plus. So that tells me when I multiply, I get the difference of squares. So 1 times 1 is 1, and if I FOIL this out, I would get a positive sine theta, and then I would get a negative sine theta. So they'll cancel, and then I get negative sine theta times sine theta will get me negative sine squared theta. Well, 1 minus sine squared theta will get us cosine squared theta through the Pythagorean identities. Well, I can look at this as being equal to 2 times 1 over cosine squared theta. Well, what does 1 over cosine squared theta equal to? That's going to be equal to 2 times secant squared theta. All right, so our next problem, which is number 5, is sine x secant x divided by tangent x. So again, I'm going to put everything in terms of sine and cosine. So sine x times 1 over cosine x divided by sine x over cosine x. So I'm going to simplify this up a little bit. I can see that this would multiply on the top, and I'm going to have sine x over cosine x divided by sine x over cosine x. I can actually see now that I have the same thing on the top as the bottom, so I know this is going to equal 1, but I can also finish it out a little bit further and say I multiply by reciprocals. We don't divide by fractions, we multiply by reciprocals. So that would get me sine x over cosine x times cosine x over sine x. So this also can tell me that these things will cancel through my cross multiplying there. And so that's going to get me 1. So I could have stopped at this point, but if you don't see that and you want to finish out, you can multiply by that reciprocal. And again, you'll see that that is equal to 1. The next one we're looking at is sine t plus tangent t over tangent t. So the first thing I want to do on this one is figure out where do I want to go. Well, I'm looking at if I separate my fractions, I end up with a tan t over tan t, which is equal to 1. So that's the first thing I want to do with this one, is I want to separate each part into 2 separate fractions, because this is equal to 1. So now I've got sine t, and I'm going to change my tangent into 1 over, or tangent t is going to be sine t over cosine t, and this will become plus 1. So again, we don't divide by fractions, we multiply by reciprocals. So here I'm going to bring it down 1 more, and I'll have sine t times cosine t over sine t. Remember, this is over 1, and still plus 1. Well, here my sine t's will cancel each other, so this will get me cosine t plus 1. And this is how we simplify our trigonometric expressions.